The human brain is the most complex structure in the universe. What you are about to view is the activity of the brain when you are feeling anxious. The anxious brain. Different circumstances, imaginary or not, may trigger emergency signals in our brain. These signals can affect our whole body. But before we explain what happens in the anxious brain, let's begin to explore the brain and its structures associated with anxiety. The cerebral cortex is the cerebum's outer layer of neural tissue in humans and other mammals, and the prefrontal cortex. Sensory functions interpreted by the cerebral cortex include hearing, touch, and vision. Cognitive functions include thinking, perceiving, and understanding language. The thalamus is the hub for sights and sounds. Some of its functions include sending the sensory and motor signals to the cerebral cortex, where they are interpreted, and the regulation of consciousness, sleep, and alertness. The hippocampus is vital to storing the raw information coming in from the senses along with the emotional baggage attached during their trip through the amygdala. The locus coeruleus receives messages from the amygdala and initiates the classic anxiety response such as sweaty palms, rapid heartbeat, and increased blood pressure. The amygdala is part of the limbic system, and its primary role is to trigger the fear response in the brain. Information that passes through the amygdala is tagged with emotional significance. The hypothalamus functions as the main control center for the autonomic nervous system. It regulates body temperature, hunger as well as thirst, fatigue, and sleep. The bed nucleus of the stria terminalis perpetuates the fear response from the amygdala, creating the unease sense of anxiety. The pituitary gland is often dubbed the master gland because its hormones control other parts of the endocrine system, namely the thyroid gland, adrenal glands, ovaries, and testicles. The activities in the brain usually take place in a matter of seconds. Fear is a normal response when something is wrong in our environment, and may turn on an anxiety response inside humans and other animals. To understand better the path of how anxiety and fear are triggered inside of the brain, let's view an example that will help us relate the physical response of a person exposed to danger with the reactions happening in the brain. This is Jack, and he is studying at the kitchen table for a nursing exam. Unbeknownst to Jack, electric cables short circuit in the kitchen, creating a fire. Jack first perceives the sound of electric sparks and the smell of smoke. The fire alarm triggers, and Jack turns and sees the stove on fire. Then suddenly the stove bursts into flames, bringing Jack into a panicked state. Without thinking, he jumps out of his chair and rushes outside of the house. This is what we commonly know as the fight or flight response. Let's observe what happens inside of Jack's brain as he reacts to the situation. Anxiety, stress, and fear are triggered primarily through the senses. The signals from the visual and auditory nerves are first processed by the thalamus, which alerts the amygdala. Smell and touch signals travels directly to the amygdala, bypassing the thalamus and the cortex. Any signals coming in from the senses that are interpreted by the amygdala as danger, whether it's real or not, triggers a direct fear response. This reaction in the brain is known as the expressway or shortcut. When fear is activated by the amygdala, a series of automatic reactions are triggered in the brain and in the body. The hypothalamus and the pituitary glands activate the adrenal glands, releasing hormones and the neurotransmitter epinephrine, also known as adrenaline. The release of these chemical messengers result in the production of the hormone cortisol, When too much cortisol is released, memories can become fragmented or lose context because it short-circuits the hippocampus, making it difficult to organize memories of a traumatic experience or a stressful situation. When these hormones are released in the body, they cause a series of involuntary reactions, such as hyperventilation, perspiration, the increase in heart rate and sugar levels, high blood pressure, muscle strength, and the suppression of the immune and digestive system. Now back to our story. What happened once Jack ran out of the house under the effects of high anxiety? He started to shake and feel that he was dying or that something was happening to his body. He suddenly remembered from his nursing studies that this was just an anxiety reaction, that his brain was imbalanced and that he was not going to die. So he helped himself out of the anxiety by saying, "I am not going to die. I am safe. It is just that I am feeling high anxiety." When Jack felt that his life was not in danger, his cognitive functions began to return. Now he is more cautious in making decisions. So he calls the fire department. And when he hears the sirens of the firefighters coming, his anxiety and fear are further reduced. What happened in Jack's brain is that after the fear response was activated and he felt he was out of danger, the nervous system started sending signals from the thalamus to the cortex, the structure of the brain responsible for thinking and decision-making. Once the cortex analyzed the raw data, it sends an all-clear signal to the amygdala in the primitive brain, reducing the levels of fear. This is known as the high road. As you can see in Jack's story, he was able to reduce his anxiety when his thinking processes came into play. Some people that suffer from high anxiety may develop what is diagnosed as a panic disorder. A panic disorder is characterized by the sudden and repeated attacks of fear that lasts for several minutes. Sometimes symptoms may last longer. These are called panic attacks, and they are characterized by the fear of disaster or by losing control even when there is no real danger. In these cases, the levels of the gamma-aminobutyric acid and the serotonin are abnormally low, and the amygdala does not respond to the signals from the cortex to slow down. Instead, the amygdala continues sending signals to the adrenal glands to pump cortisol and adrenaline into the nervous system, so the whole body remains on high alert. In some cases, medication and psychotherapy may be helpful to treat patients with panic disorder. This is a general representation on how the brain and the body react to fear and anxiety. How we think and what we believe can influence the amount of anxiety we experience. What we tell ourselves does matter. And about Jack, the firefighters were able to get there on time and put out the fire. His kitchen suffered some damage, but he was able to fix it, and he called an electrician to check all the electrical system in his apartment.